Welcome, ladies and gents, to another flipped lesson. Today our focus is on understanding what is meant by the terms physical properties and changes and chemical properties and changes. This covers pages 76 through 79, 82 through 83, and 86 in your text. Let's get started. So what's a physical property? Basically, a physical property is something that's going to be a description. So it's a quality or condition of a substance that can be observed or measured without changing the substance's composition. So these are things that you would use to describe a chemical to a friend in the lab. Maybe saying if it has a color, like the compound is white. Maybe it has a texture, it's really grainy. The substance's boiling point or melting point for that matter, whether it's ductile or malleable. These are all different things that we can use to describe chemicals to someone that are denoting the physical properties of that substance. So these are more of your kind of description-based items. A physical change then is going to be something that alters one of those physical properties. But the big thing in this definition is it's not going to affect the chemical composition. So it's going to remain the same compound, just altered a little bit. So for example, cutting. If I take a piece of magnesium ribbon and I cut it in half, I haven't chemically altered the ribbon. It's still magnesium metal, it's just now in two pieces instead of one. If I grind something, so if I take a sugar cube and I take it from cube form into powder form by grinding, it's still that same sucrose compound, it's just now in a powder form as opposed to a cube form. If I take a piece of metal and bend it, it's still the same metal, it's just a different shape. Or if I dissolve any solid, so when I take salt and I dissolve it in water, I'm not chemically altering the salt at all. The Na and Cl ions are still present, they're just free floating in the water instead of being stuck to each other. Some other examples would be your state changes. So putting heat in to melt a solid, removing heat to freeze liquid, or adding heat to boil a liquid. Anytime you're kind of going between states of matter, so from solid to liquid or liquid to gas, it's going to be a physical change. Because if I take an ice cube and I melt it, it's still water, it's just now a liquid form instead of a solid form. So the big thing about physical changes is they're all going to be reversible. If I melt something, I can go back and I can freeze it. If I take a piece of metal and I cut it, I can, in theory, melt it down and get that solid piece of metal back. So these things are all going to be reversible in nature. Now, one thing we can do with our physical properties is we can use them to separate different types of mixtures. And one of the most common forms of separating a mixture that we use is through distillation. So some of you have drank distilled water before, and that's what process you see depicted here. So we use distillation to separate out homogeneous mixtures. So for example, if I have salt water, I'm going to use the physical property of boiling point to separate the salt from the water. So how exactly does that happen? What you'll have is you'll have a heat source on one side that's going to heat up whatever solution it is that you're boiling. In this case, it's some sort of impure water. What's going to happen is the water is going to be evaporated off from the solution, and whatever's in the water is going to remain on the other side. That steam moves through this thing here called the condensing tube, and what this condensing tube does is it cools down the steam back into liquid water that is then collected on the other side. So you can see that this was a reversible process. I had water on one side, I evaporated it into steam, and it came back out as pure water on the other side. So it's a physical process because it was reversible. Another technique we can use to separate mixtures is filtration. We use this typically to separate solids from a liquid. So let's say I had a beaker of sand water. I could use a funnel with some filter paper in it to separate my water from my sand. The sand is too large to pass through, so it'll get trapped in the filter paper, where my water then will be collected on the other side. And this again is reversible because I can go ahead and I can mix the sand back in my water and get that mixture back. So if a physical property is something altering, or is a physical appearance, and a physical change is altering a physical property, a chemical change then is going to alter the chemical composition. So chemical properties and changes are all based on the ability of a substance to undergo a chemical reaction and form new substances. And that's the really important part of this definition, is we are making new stuff out. So our compounds are going to be chemically different at the end than from what we started with. Some examples of different chemical properties are how easily you rust. Not all metals rust at the same rate. For example, iron, which you see here in the picture, rusts really, really easily. It'll combine with oxygen in the air to make iron oxide, and that's that brown flaky stuff you see here in the picture. Regular iron looks like nice shiny silver, so we can see that it's chemically different than what we started with. Other examples are how easily you combust. So for example, not all things burn at the same rate. A piece of paper put in a fire is going to go up in flames immediately, where if I put a plastic jug into the fire, it's not going to actually burn, it'll melt. So they have different combustion rates. How easily you decompose is also another example of a chemical property. So if I decompose really, really well, I'm going to be chemically broken down, where other things don't decompose that well. So let's review. I'm going to throw up some examples here, and I want you to go ahead and hit pause on the screen and see if you can figure out what is physical and what is chemical. So the fact that you're back makes me think that you have given your best guess as to what these things are physical and chemical. So cookies being baked are in fact going to be a chemical change because we have something new out in the process. Water boiling is going to be physical because all we're doing is taking liquid water and turning it into steam. Salt dissolving in water is also going to be a physical change because we're just separating the ions with water. We're not chemically altering the compound at all. The firefly emitting light is definitely going to be chemical. It's a chemical reaction that happens in its belly. Milk spoiling is chemical because the proteins are being denatured and turning into something different. And a metal chair rusting is also going to be chemical. Now, how can we tell if a chemical reaction has occurred? What you want to look for is you want to look for a change in energy. In chemical reactions, energy will always be absorbed or given off, and you can figure that out through a temperature change. So if you have two things at room temperature that either spontaneously get really hot or really cold, you have energy either being given off or absorbed. So example, when you burn the gas on your stove, the heat you feel is from heat being given off through that combustion process. But be careful, a temperature change is not always going to indicate a chemical reaction. When we boil water, we have to heat it up in order to get it to change from a liquid to a vapor. So in this case, we are putting heat in, but it is a physical process. So oftentimes, if you see an energy change with some of these other things, maybe a change in color, a change in order, gas production or production from a solid from a liquid, that could also mean that you have a chemical reaction taking place. So this first picture is showing us the production of a solid from a liquid. We've got lead nitrate and sodium chromate that are reacting to make this red precipitate that looks like a cloud. You know it's a solid because if you let it settle, all the solid particles would be at the bottom of the test tube. Aside from seeing a solid forming, we also have a color change from yellow to clear to red. So those are two signs of a chemical change. In this reaction over here, we've got zinc metal and sulfuric acid making a lot of bubbles. So we see that we have a gas produced. If you felt the test tube bottom, it would also be very, very warm, showing that we've got energy given off. So if you're looking to see if it's a chemical change, typically if you have at least two of these, in addition to an energy change, or an energy change in like one of these things, it usually means that you have a chemical reaction taking place. But just be careful, because all those examples that I gave you can mean that it's a physical change. So you really have to look and see what is going on. When we make Kool-Aid, we take a powder and we put it in water, and that water goes from clear to red. So that is a change in color. But it's just a physical process because we're dissolving the Kool-Aid. So when you're looking for something like a change in color, we're looking for something dramatic. Maybe we went from like yellow and clear like you saw to red, or we went from two clear solutions to something colored or white. So we're looking for dramatic changes in color or significant increases in heat, a lot of bubbles, things of that nature. Now the number one sign of a chemical reaction is irreversibility. Physical things are easily reversible. The water will melt and freeze easily, while chemical changes cannot be easily reversed. I can't turn rust back into iron and oxygen without another chemical reaction. So go ahead, fill out that Google form you see next to this video, and we'll review some of this stuff. And please make sure that if you've got any questions, you type them in the questions box. See you soon.